Okay, so today we're going to be reviewing two chapters, Chapter 5 and Chapter 6 on exponential functions. It is the work of 5 weeks and 1 day. Are we clear? Yes. So an exponential function has a base, which is our multiplier. And it's basically defined by f of x equals a b raised to the x, or y equals a b raised to the x. In the following example, your a equals 1, your b equals 2, and it has this pattern. One of the key features is that there is an asymptotic value right here. The function will forever reach this horizontal line. In this case, it happens to be 0. But it'll never reach it, and it'll never cross it. You can't cross something that you can't reach. Here are examples of how to evaluate this. -2, that means your base. 2 raised to the -2, 2 raised to the -1, 2 raised to the 0, 2 raised to the 1, blah, 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 blah. Most exponential functions will have this shape, and we'll talk about this is growth. That's because a is greater than 1. This is the parent function. From where all transformations take place. This graph does not have a constant rate of change. So if I were to try to draw a line, you see if I connect this point and this point right here, do y'all see the slope that it makes? Yes or no? But if I try to connect this one with this point, does it have the same slope? No. So the rate of change is not the same. So this is not a straight line. So that's what they mean by this graph does not have a constant rate of change, but it has a constant ratio, a constant multiplier. Vocabulary is going to be super important, a constant factor. The R for ratio is not the R for the interest rate. Features of this graph: the domain is all reals. The range is all positive real numbers, not 0, for this one in particular. The domain is all your x values, so that's why it goes from -infinity to +infinity. Clear? But the range, it cannot go below this line. So y cannot be less than 0. So that's why your range is going to be greater than 0. It can never be 0 because 0 is the asymptote. And remember, the function is reaching it, but never getting there. It's trying to reach it, but never gets there.
Wouldn't that be equal to or greater?
No, because it cannot be 0. So the rate, in this case, can the asymptote be a different line? Yes, if we have a transformation where you're moving up or moving down, the asymptotic value can change, but once again, the function will not be able to reach that value. Graph has a y-intercept at 0, 1. There we go. Remember, any number to the 0 power is 1, so 5 raised to the 0 is 1. 2 raised to the 0 is 1. 100 raised to the 0 is 1. When b is greater than 1, the graph increases, and by that we mean this. When b is between 0 and 1, the graph decreases, and by that we mean this. Asymptote value, a line that the graph gets very, very close to, but never crosses or touches. So for this graph, the asymptote is the x-axis, or y equals 0. All right. If we have a table, how do we know that it's exponential? First of all, make sure that this difference of the x's is constant. What's the constant difference here? Plus 1. And then check that this is a constant difference. Whereas over here is a constant multiplier. So that means 1/2 divided by 1/4. 2. Then is it going to be 1/2 divided by 1 or 1 divided by 1/2? 1 divided by 1/2. Is it going to be 1 divided by 2 or 2 divided by 1? 2 divided by 1. And 2 divided by 1 is equal to 2. Is it going to be 2 divided by 4 or 4 divided by 2? 4 divided by 2. And once again, what is 4 divided by 2? 2. Last time, is it 4 divided by 8 or 8 divided by 4? And 8 divided by 4 is 2. So that means the multiplier is 2. 1/4 times 2 is 1/2. 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. That's the base. All right, so as x increases by 1, y increases by a factor of 2. Okay? These are things that you have to know. This is given to you in the formula sheet. This is not given to you in the formula sheet. This R is not the multiplier. This is an interest rate. I'll say it again. This R is not the multiplier. This R is not the number that we get when we do this, the division of the y's. This is the interest rate in decimal form. And if it's decay, it's 1 minus R. The whole thing is the multiplier. The multiplier is the 1 plus the interest rate in decimal form. So if you have the interest rate in decimal form and you add 1, you get the multiplier. If you have the multiplier and subtract 1, you get the interest rate in decimal form. So please make sure that you understand that relationship right there. Half-life. Half-life is going to be y equals a. The multiplier is 1/2 because we're multiplying by 1/2 every single time. Raised to the t over t half. Basically, raised to the time divided by the half-life. This is very important that you remember what your exponent is. The total time divided by the half-life. Doubling is y equals a, 2 raised to the t divided by the doubling time. So the total time divided by the doubling time. Tripling is 3 raised to the t over the tripling time. It's literally time divided by the tripling time. Time divided by the half time. Time divided by the doubling time. Time divided by the tripling time. Do you see the pattern? You cannot forget. Is this given to you in the formula sheet? No. So put a big star that says, must know this from the bottom of my brain. Same thing for growth and decay is not given to you, so you must know this from the bottom of your brain. It is 2 units. If we look right here, exponential functions is going to be part of the 60% or the 70%. Because it's both functional and graphical reasoning, okay? All right, compounding formula is in the formula sheet. What it means is not. So you need to know that A is the balance, P is the principal, R is the interest rate in decimal form, T is time, and N is how often you're compounding. This is also not in the formula sheet, so you need to know it by memory. Clear? Any questions so far? This is literally just about 80% of everything from chapter 5 and chapter 6. Questions? All right. I specifically told you which are the ones that you need to know by yourself because the formula sheet does not give you. All right, make a table for this function using the given domain. Domain is your x values. Then graph the function using the order pairs from the table. So this is the function. F of x is equal to 3 times 2 raised to the x. Who represents A and who represents B? By looking at this function, who represents whom? Correct. A is 3 and B is 2. This is the domain, ergo, these are your x values. Keep up. Make sure your devices are put away. All right, so now you have to be able to use your calculator for this or your decimals is your choice. All right, so please don't make me wait and start calculating values for me. All right, so let me see. Alana's going to be this one. Pedro's going to be this one. Kamori is going to be this one. Nevia is going to be this one. Let me pick somebody from the back. Jacob is going to be this one. Don't make me wait. You have one thing to calculate. Counting to Alana, what's the y value here? You're making me wait. It's only one number to calculate. The rest of you, please be ready so you're not making me wait. We're reviewing 2 units in one day. All you have to do is 3 parentheses 2 raised to the negative 2. Any questions? So what do we get, Alana? Three over 4. All right, Pedro, what do we get? Q. Kimori, what do we get? Nevia? Jacob? All right, so now plotting points. 3/4 is what? About 0.75? And 3/2 is about 1.5? Okay, so at negative 2.75, so somewhere there. At negative 1, 1.5. At 0, 3, 1, 2, 3. At 1, 6. Oop, and now we're off scale. Are we clear? So, is this growth or decay? It is growth. Okay, so let's see. That was just one? That was just one? That's all they want to draw a line from the function to the matching graph. Label the end behavior for each function. End behavior. Something you should know. Okay, so when you look at this, oh, I forgot to mention this in the front. We'll write it here. Y equals A, B raised to the X plus K. That is the asymptote. The constant at the end, if you're adding a number, that's the asymptote. So in this case, since we're not adding anything, the asymptote happens at 0 at y equals 0. So when you look at this one, you see 5, 2 raised to the x. Is there a constant at the end? Is there a constant at the end? There is no constant. There is no plus a number or minus a number, okay? So that means that the asymptote is y equals 0. Is there a constant at the end here?
No.
So that means your asymptote is at y equals 0. Same thing here. There is no constant at the end, so that means that the asymptote is y equals 0. So that's not going to help us because they all have the same asymptote. Clear? So we can't tell them apart by the asymptote. So now let's try something else. Let's try the y-intercept. Which one is the y-intercept? The y-intercept is your initial value. Okay, this is something you need to know. A is equal to the initial value, which happens to be the y-intercept. You need to know this. So when I look at this function, I know that the y-intercept happens at 5. Please put the phone away. Completely away. Did you sign in? Okay, so over here, what's my y-intercept going to be? -2. And in number 4, what's the y-intercept going to be? 3. All right, so let's see if that helps us figure out. I know it's kind of small and tiny, but you guys have the paper in front of you. Which one do you think has a y-intercept of -2? Number 2, number 3, or number 4? Right there, right? Y-intercept of -2? Then between these two, which one has a y-intercept of 3 and which one has a y-intercept of 5? It's kind of hard to tell, right? 1, 2, 3. This one goes by ones. So I think this one is y-intercept 3. If it was much more clear, it'd be a lot easier, but basically you're looking for the one that crosses at 3, okay? And then this one is going by 2s, I think. Yeah, it is. See, 2, 4, 6, 8, -2, -4. So it'd be 2, 4, so then that's 5, y-intercept of 5. And now you can match them. So we use their characteristics to figure out who's whom. Can somebody tell me a different way on the milestone to do this? Desmos. But Desmos only graphs for you. You have to know what you're looking for. You have to know the characteristics. Are we clear? All right. Basic math when it comes to this. I want to isolate this. So that means I have to get rid of this 2 over 3. So do y'all know that we can multiply by the reciprocal? Yes? Since this is 2 over 3, we're going to multiply both sides by 3 over 2. Why do we do this? Because this is a handy technique. The 3's cancel, the 2's cancel. And now you only have 1/2 raised to the x equals, what is that? 1 times 3 is 3. What's 3 over 12 reduced in the calculator? Do we all agree, or are we all just going to go with that number? All right, y'all see? So then, and this is raised to the 1. Clear? Are they the same? Can we say that x equals 1? No, because they don't have the same base. What's the base over here? 1/2. What's the base over here? 1/4. So something else that you should know is that 1/2 times 1/2 is equal to 1/4. So literally that means that, watch the math here, okay? That means that 1/2 squared. So this means that this is 1/2 squared. Right? When you multiply 1/2 by itself, when you multiply any number by itself, you're squaring it. Yes or no? Yes or no? So then this is literally 1/2 x is equal to. Now do they have the same base? 1/2 and 1/2. So therefore x must be equal to 2. All right, the value of a textbook is 69. So when you read this, this is your initial value. And decreases at a rate of 15% per year. Okay? Going back to the front, what type of problem are you looking at? 15% means exponential. So you're not linear, you're not quadratic. 15% means it's going to be exponential, but which exponential? It's decay. Is this going to be in the formula sheet for you? No, it's not. No, it's not. In fact, you should take out your formula sheet. What's the only thing that is in the formula sheet? Y equals AB to the X. So you need to remember, practice, write index cards, the growth formula, the decay formula, the half-life formula, doubling formula, tripling formula. The compounding formula is on the formula sheet, but does it tell you what is A, what is P, what is R, what is N, or what is T? Does it tell you anything? No. So you need to know what they are and how to decide what the compounding value is going to be. Memorization, clear? All right, so we know it's going to be decay because it says decreases. We know it's exponential. Why? Why do we know it's not lit? Because it's got a 15%. That's how you know it's exponential. It's not linear, it's not quadratic. We're doing linear on Monday, we're doing quadratics on Tuesday. 15%, this is the interest rate. How do we write that in decimal form? You have to know that as well, how to go from percent to decimal. What is the value of the textbook after 11 years? This is your time. So then you start off, oh, this is decay, so this is going to be y equals a, 1 minus r raised to the t. A is my initial value, which is 69. 1 minus not 15, but 0.15 raised to the 11, because time is 11. Okay. Let me see you. Is it 11.5? Money. So after 11 years, your textbook, you're only going to be able to sell it for $11.54, even though you paid $69 for it, okay? Ain't nobody want no older textbooks. Okay, question. Okay, review, remember? The value of a boat is what? Depreciating at a rate of? So how do we know that this is an exponential function? 7%. It is not linear, it is not quadratic, it is exponential. But your formula sheet only gives you that and this one. Okay, let's keep on reading. In 2004, the boat was worth $192,000. Find the worth of the boat in 2013. So what do we have? Is it growth, decay, half-life, double life, triple life? Decay. Clear? So y equals a 1 minus r raised to the t. All right, what is a? Correct. The interest rate is 7%, but how do we write that as a decimal? And then the time, whoa, they didn't give me time. What do I do? Okay, so how much time went by from 2004 to 2013? I am going to call on somebody. Like we say in Honduras, Tin Marín de dos pingüín, tu tramatra títere fue. Fue tete, pégale, pégale, que ya fue. Aaliyah. Not there yet? No. Traquan, what's the answer? Come on. Let me see. Sanai, what's the answer? But I saw you just sitting there doing nothing. No, we know that already. I already put it there. I'm talking about here. Okay, but what I was asking for is this. Say that again, Justin. No, usually with money, they want those two decimal places. So where did we get lost, and why did people think I was asking for the 9 when the 9's already there? Can we stay focused? Move to the front if you have to. If I see you idling, I'm going to call on you because obviously you're done doing nothing. Huh? It's not 9-0. What is it? 9-3? What do you mean all numbers can be rounded? What is this? .93. 0.93. Are we clear? 0.93 is 93 cents. All right, a painting is sold for $1,800 and its value increases by 11% each year. Is this linear, quadratic, or exponential? Exponential, but your formula sheet only gives you y equals ab to the x. So what do you have? Growth, decay, doubling, tripling, half-life? So you need to know this. All right, hurry up. Identify your A and identify your what is A? 1,800. Yes, Pedro? What? Increases by 11%. What is 11% as a decimal? After how many years? Now, Everybody should be going for that calculator. Let me see who's not going for the calculator so I can call on them. Oh, and I'm recording it, so what is it, Elijah? Do you agree, Savannah? All right, please make sure you're getting this number. This is a great time to figure out if you typed it in wrong. Okay. Darlings, I'm making a recording of this. Like I said, we have 2 chapters in one day, and if you notice, there's 2 packets on your table, top. So does the following table represent an exponential function? So the first thing you do is you check, this is changing by how much? We're adding 1, right? 1 to 2 means we're also adding 1. 2 to 3 means we're also adding 1. Check. That's one mistake that students make, is they don't check to make sure that the x's are increasing constantly. They'll play that game. So now, when you look at these numbers, do you think it's linear?
No.
Why not? It's going up too big. If it was constant, if it was linear, it'd be going up by the same number every single time. So from 5 to 15, it was 10, right? But if you add 10 to 15, do you get 45? So it's not linear. Could it be quadratic? We don't know. But since it's jumping so much, we're thinking exponential. Clear? So what am I going to do? 5 divided by 15 or 15 divided by 5? All right. So now these two, what am I going to do? 15 divided by 45 or 45 divided by 15? All right, there's only so many times that I can make you repeat this for you to remember this. Are we clear? What are you going to do? 45 divided by 135 or 135 divided by 45? And in all cases, your multiplier is 3. I'm going to repeat this again. Multiplier. Your factor, your b equals 3. Base, whatever people want to call it. So does the following table represent an exponential function? Yes, because it has a constant multiplier. A constant factor of 3, a constant multiplier of 3, clear? Something like that. Factor, when two numbers are factored, then when you multiply them, you get products, okay? So it indicates multiplication. And then multiplier indicates multiplication. But if it's just a constant difference, that involves addition or subtraction, okay? All right, so which of these sets of ordered pairs satisfies an exponential equation? So when we were dividing the y values. Are we clear? So I check -1, 0, 1, 2. You see how the x's are changing by 1? So now what are you going to do? 0.4 divided by 2 or 2 divided by 0.4? Excellent. And all of these are changing by 1s. Okay. So yeah, so go ahead and check your y values. Miles, you're sitting there doing nothing. Why? Grab your calculator, type in 2 divided by 0.4. Grab your own calculator. I'm only working with Miles right now. You're working on your own. Good, write it down on your paper. You didn't have a pencil out yet? Oh, you fell? Okay, quickly, we gotta move on. All right, what are you gonna do, Miles? 2 divided by 10 or 10 divided by 2? 10 divided by 2, correct. So what do you get? So multiplier of 5. Now, Miles, what are you going to do? 10 divided by 50 or 50 divided by 10? Correct. 50 divided by 10. And what's the multiplier? Honestly, that one looks like that's the answer, right? The other ones are probably not going to meet this. This is 1, 4. And this one would be 4 over 1, which is 4. So 1/4 is not the same thing as 4. Huh? She's not a neurosurgeon. Where's your pass? Uh-huh. Sorry, Joshua has to go. Okay. Can you all not let me forget about these passes because honestly, I'm not thinking about them. Clear? Joshua, here's your bathroom pass. All right. This one you should know how to do. Number 17. Math. Please learn math. Here we go. This literally means negative 2k to the negative 2 times negative 2k to the negative 2. Anything squared is the number multiplied by itself. Clear? So does anybody know what negative 2 times negative 2 is?
Positive 4.
Y'all sure? This is not the time to just be copying what's on the board. And k to the negative 2 times k to the negative 2?
K to the positive 4.
Wrong. What do we do with exponents? We add them. So what's negative 2 plus a negative 2?
Negative 4.
So this is 4 times k to the negative 4. And if we want to clean this up some more, it's 4 over k to the 4. Okay? Miles, it's not going to happen if you don't write it down. Okay. Just reminding you, we're recording, and your name's popping up a lot. All right, this one. So y'all remember that this is over 1. So this is 6 times x to the 18 over 24x squared, correct? All right, grab your handy dandy calculators and do 6 over 24. Or basically, how many times does 6 go into 24? 4 times? So 6 goes into 6 1 time, and 6 goes into 24 4 times. Now, you have 18 x's, and we're going to take away 2. How many do we have left?
6.
Yes, when we multiply, we add them. When we divide, we subtract them. Are we clear? So this is 1/4 times x to the 18 minus 2. When we multiply, we add them. When we divide, we subtract them. Make sure you play that a lot in case you need to play it over and over in the video, okay? All right. Suppose 25 E. coli bacteria are introduced into some food as it's being processed. And the bacteria begins what every minute? Tripling. What type of function is this?
Grows exponential, sorry.
Exponential. The only thing that triples is exponential. Are we clear? And that means that your base equals 3. Your multiplier is 3. Your factor is 3. Your b is 3. Clear? That's what that means. And complete this table showing the number of bacteria. So at time 0, we had how many? So at 1 minute, we have how much? 75. And how did we do that? Exactly. Grab those calculators because the number's about to get big. Stop being lazy and just writing numbers down. You're supposed to be proficient on the milestone, which means that calculator should be used. Grab the calculator. What are you going to multiply the 75 by?
3.
Your answer, what are you going to multiply it by? Let's go, because I'm going to call on you. Let me see. This one is going to be, so there's going to be Bryce. Let me see. This one's going to be Zeal. This one is going to be Hannah. Are we all done? This one's going to be Alex. She made eye contact. And then this one's going to be Miles. All right, let's go. Don't let me down. You have more than enough time to get your answer. All right, 75 times 3. Bryce. Thank you. Zeal, 225 times 3. Hannah, 675 times 3. Louder. 2025. Alex, 2025 times 3. 6075. Okay. And Miles, 6075 times 3. How much? All right, do y'all agree? Yeah. There you go. Easy question. We need to write a formula relating the variable x, the number of minutes, to the number of bacteria present. Well, we said this was exponential, right? Yes. So if you go to exponential, it says y equals ab to the x. Write a function. So function implies f of x. I told you this, right? Expression has no equal signs. Equation has an equal sign, and we usually use y. And when we say function, we usually use f of x. All right, so f of x is going to be equal to a times b to the x. What is a? It's going to be 25. And what is b? No, b is the multiplier, the factor, the base. We already established that the factor, the base, the multiplier was, because this is tripling. If it was doubling, it would be 2. If it was half-life, it would be 1/2. So f of x equals 25, 3 raised to the t. Oops, sorry, x. So this should be x. My bad. Thoroughly apologize. They want x because they called x minutes, right? So we should stick to x. Okay. After 20 minutes have passed, how many bacteria are present? So what do we do? Plug it in, plug it in. Do y'all know what plug it in means? So in the calculator, it should be 25, 3 to the 20. Let me look right here. So it's going to be a big number. Okay, and then it says round to the nearest hundredth in scientific notation. Okay, so the nearest hundredth, that's what, 2 decimal places? So I want the 8, the point, the 7, the 1, but the 1 is going to move up to 2, correct? So it's going to be 8.72 times 10 raised to the 10. Where'd I get that from? From over here. All right, each of these problem situations involves either a linear function or a exponential function. Decide whether it's linear or exponential. Let's start with that. Read A, read B, and read C. And then circle one of these, circle one of these, and circle one of these. And then after I say 1 minute, 30 seconds, I'm going to call on 3 people. Miles will be one of them. All right. Okay, you're just reading the first sentence. We're just determining whether it's linear or exponential. All right, Miles, 1,000 is placed in a savings account. Each year, the account value grows by 3%. Is this linear or exponential? Exponential, what gave it away? The 3%. Let me see. Christina with a K. Suppose that a school has an enrollment of 2,000 students at the start of the school year. Each month, the enrollment grows by 5 students. Linear or exponential? It is linear. What gave it away? It grows by 5. It's growing by a constant number, okay? Not a constant multiplier. Trey, sports team begins a season with 50,000 fans. Each time the team loses a game, it loses 3% of its fans. What gave it away? The 3% gave it away. Are we good? Okay. So then exponential is y equals a b to the x. Linear is y equals mx plus b. This is y equals a b to the x. Okay. It grows by 3% is what type of exponential function? So we're going to use the more expanded one, which is clear? All right, I'm not going to go that slow because we have a lot of material to make sure that we get to. So this is 1,000. 1 plus, what is 3% as decimal? Beautiful. Raised to the x. So it's going to be y equals 1,000. 1.03 raised to the x. The school starts with an enrollment of 2,000 students, so that means the starting initial value is 2,000. And it's growing, what's the slope? 5 students per month. You see how that's a rate, students per month? So this one is 5. So this is y equals. Okay. Let me see, Trey, is letter C growth or decay? Yes, decay. So it's going to be y equals a 1 minus r raised to the x. They're using x, which is why I'm sticking to the x. If they use t, then I would put a t, okay? So they're kind of sort of deciding our variable. All right, Miles, let's go start writing it down, unless you already wrote it down, which means you're ready to share. Who wants to share this one? Go, Savannah.
50,000.
A?
Yes.
Uh-huh.
In parentheses, 1 minus 0.03.
Okay. So if we clean up the base, what's the number inside the parentheses? What is 1 minus 0.03? Point what? There we go. Okay, more practice here. A major newspaper had what? 200,000 subscriptions in the year 2000. The number of subscriptions in each year since then is given by this function, where X stands for the number of years since 2000. So 2000 is our first year, okay? Times 0. All right, I'm gonna give you 1 minute to talk to a partner. I want discussion. I don't want you sitting there. I want you to talk about A, B, and C. Go. All right, good job, good job. Joshua. What's going on? All right, are you trying? Are you trying? The course? I'm sure that probably means that you're gonna go the business route.
I'm thinking that, or I'll look at the clock and say 10 or something in technology like science.
Good choices, good choices. All right. A, has the number of subscriptions been getting bigger or smaller? Bigger. How do we know? What do you mean what?
No, it's been getting smaller.
Smaller. What? Smaller. Who's less than 1?
B is less than 1.
Yeah, 0.89 is less than 1, so it's getting smaller. Your multiplier is a number between 0 and 1. So you're only keeping 89% of your subscribers. Okay. What is the rate of increase or decrease?
11%.
Or 11%. The decrease is 11%. Because 1 minus 0.11 is equal to? Please make sure that you review these questions and you understand when are they asking you for B and when are they asking you for that part of B, for the R. All right, which of these is the shape of the graph? The last one? Yes. And how many subscriptions will there be in 2008?
0.
Wait, when was year 0? The year 0 was what, 2000? So how many years have passed since it's now 2008? 8 years. So you got to do 2008 minus 2008. So we're doing f of 8. So what? Recalculate. All right, 78,731 or 32?
32.
Okay. So why didn't I use 2 decimal places or 1 decimal place? Because these are people, right? We can't have 0.5 of a person. That would be murder. And I don't want to go to jail. So here we go. All right, more. So do you think we're reviewing exponential functions? All right, the table below represents, we'll leave this one. Let's look at the other packet. All right, the squirrel population in the forest has grown at a constant percent rate. 30, either one?
No, I got the other one. You just changed it.
Okay. All right, constant percent rate. So it's exponential. The table shows the number of squirrels in the forest over a 3-year period. What is the constant percent rate of change of the squirrel population? Okay, what's the multiplier, first of all? So Miles, what are we doing? 1,000 over 1,100 or 1,100 over 1,000? Excellent, but you're not doing it right now. How are you going to give me the answer if you're not on that calculator? A 100? No. 1,100 over 1,000. 1.1? Are you guys sure? Let me just do my. Okay, Miles, what is 1210 over 1,100? Okay, so it's growing by 1.1. So the multiplier, pay attention on this, the multiplier is 1.1. This is B. B is 1.1. Clear? Is this growth or decay?
Growth.
So that means that 1 plus R is equal to 1.1. Clear? So that means that R is equal to 0.1. Clear? Because 1 plus 0.1 gives you 1.1. All right, and this is in decimal form. What is that in percent? You guys have to be able to change this into a percent. Multiply it by 100. Move the decimal twice to the right, so it's 10%. So it is changing by 10% every single year. That's why we're multiplying by 1.1. If it says it's increasing by 10%, what do? You turn the 10% into 0.1, you add it to 1, and the multiplier becomes 1.1. All right, pay attention because this comes straight from the practice of Georgia DOE. This one. The graph of the exponential function shown on the coordinate grid represents the cost in dollars to make a container of raspberry jam. Yes, these are the questions. Which function represents the cost in dollars to make a container of the raspberry jam? So now you can use decimals. Correct? But we don't have decimals right now. So what are some characteristics that we can use? What's the y-intercept? 2. So that means your a value equals. So that means we cross this one out. Oh, we also cross out which one? Okay, so now is this growing or decreasing? So this is growth, so that means your B has to be greater than 1. So which one is the answer, A or C? You see? All right, consider the function for cell duplication. The cells duplicate every minute. What do the values 75 and 2 represent in relation to the duplication of these cells? I'm going to give you a moment to reread the questions, the answer choices. Remember, you have it in front of you. Please be active. I know we've been working hard. We have a few minutes left. Let's go. Take it seriously. I'm trying to put you in an environment where you're in the milestone. All right. All right, which one can we cross out and why? We're crossing out C, why? That's not true, right? What is 75? Okay, so the only one that says 75 is the initial amount is these two. So that means we can cross these out. So now, what does the 2 represent? So which one says that? There we go. Yes, the 2 means it's doubling, okay? This would be linear, increases by 2 every minute. So that's plus 2, plus 2, plus 2. Whereas this one is times 2, times 2, times 2. All right, more questions from the study guide. Candace has a savings account. The total amount of money in dollars in the account in relation to the time in years. I feel like I didn't read in English. Candace has a savings account. The total amount of money in dollars in the account in relation to the time in years since Candace made her first deposit can be described by this equation. Level 2, because they're giving us the equation. Are we clear? Move each part of the equation in the table next to the term that best describes what it represents. Not all parts of the equation will be used. So here are your choices. Place them in the right spot. Go. It just says move each part. But we can't do drag and drop on paper. So decide which one you're going to drag next to initial deposit, growth factor, time, and interest rate. Focus. We have about 5 to 10 more minutes. All right, maybe more like 3. You think you can do it? Who thinks they're going to match them up correctly? Okay. All right, let's see who's going to match them correctly. Should I call on Miles? You guys think so?
Yeah.
Huh? Let me see who looks like it. Kimori? All right, I'm going to randomly pick students. Are we clear? All right, let me see. Justin. Zio. Let me see. Journey. And let me see. Anushka. All right, let's see. Justin. 3,000. If anybody thinks he's wrong, y'all got to say something. Zio, what's the growth factor? Huh? 1 point. All right. Anybody say she thinks she's wrong, maybe? All right, Kali, which one is time? T. And which one, who was A? Anushka, what's the interest rate? The interest rate is this one because this is 4%. Factor. B. Multiplier. Factor. Base. B. Are we clear? This is right. All right. So can we keep these safe for the entire week? On Monday, we'll start off, we'll finish these questions, and then we'll move on to linear equations. Clear? There's a milestones review tomorrow. They're always